Hey guys, it's Mrs. Wilkin. Today we are going to continue looking at section 6.4. We are going to solve absolute value inequalities. Yesterday we were solving absolute value equations. So let's do a little bit of review before we start with our inequalities. Number 1, the absolute value of x minus 5 equals 2. Remember, to begin you want to break your problem into two different equations. X minus 5 equals 2 and x minus 5 equals negative 2. Then we're going to solve both of these problems individually. Add 5 to both sides, so we get x equals 7. Now let's solve the other problem. Add 5 to both sides of your equation, and x can equal 3. So our solution to number 1 is that x can equal 7 or 3. Number 2. Remember, before you break it into two problems, you have to make sure that that absolute value is by itself on one side of your equation, which it is. So let's go ahead and break it into two problems. 2x plus 1 equals 5, and 2x plus 1 equals negative 5. Solve both equations. 2x equals 4. Divide both sides by 2. So x can equal 2, or subtract 1 from both sides. 2x equals negative 6. Divide both sides by 2. X can equal negative 3. So in this problem, x can equal 2 or can equal negative 3. Let's move on to problem number 3. Notice that in this problem, our absolute value equals a negative number. Absolute values will never equal negative numbers. So this problem has no solution. Let's get started with absolute value inequalities. Before we can begin to solve an absolute value inequality, you must determine if it is an AND graph or an OR graph. To do this, we look at the inequality symbol at the beginning of the problem. If the symbol is a less than symbol or a less than or equal to symbol, we can try and remember this little helpful phrase, less than. That tells us that our graph is going to be an AND graph. If our symbol is a greater than symbol or a greater than or equal to symbol, we can try and remember the word greater. Again, keeping in mind that the word or is in the word greater, so that reminds us that our graph is an OR graph. So let's just look at these three examples, A, B, and C. Letter A, this is a greater symbol, so that tells me that it's going to be an OR graph. This is a less than or equal to symbol, but less than rhymes with and, so that tells me it's an AND graph. And here we have a greater than symbol, so if I say greater, that rhymes with OR. Now that we can identify if the graph is an AND graph or an OR graph, let's start by looking at the less than inequalities. Number 1. Let's go ahead and break this into two problems just like we would with an equation. You want to make sure that your absolute value is isolated on one side of the inequality. In this case, it is. So now we can continue to break the problem into two different inequalities. The first one, just like with the equations, is going to remain exactly the same, but without the inequality or the absolute value bars. Now, we want to look at our symbol. Notice that our inequality symbol is a less than symbol. That tells us that we need to use the word and. So in between the two equations that we write, or inequalities that we write, make sure that you write your word. All right, now let's go ahead and write our other inequality. The second inequality, 2x plus 1, but we have to flip our sign when we make this value negative. Now we have our two inequalities and we can go ahead and solve both of them. Subtract 1 from both sides. 2x is less than 4. Divide both sides by 2. So x is less than 2. And let's solve the other side. Subtract 1 from both sides. 2x is greater than negative 6. Divide both sides by 2. X is greater than negative 3. So our solution is that x is less than 2 and greater than negative 3. Now, does this ask us to graph? Yep, it sure does. So remember, with an and inequality, we want to know where will those graphs overlap. We want values that are less than 2, so here's 2, but also greater than negative 3. So we want to find where all of those values in between negative 3 and 2 are. So there's your solution and there's your graph. Now remember, you can rewrite your and compound inequality differently. If you want, you can write your variable in the middle using less than symbols and write the smaller of the two numbers on the left and the larger of the two numbers on the right. So either of these two answers is acceptable. They both mean the same thing. All right, let's look at number 2. Number 2 is x minus 5 is less than or equal to 6. So again, let's go ahead and start by separating our inequality into two separate problems. We have x minus 5 is less than or equal to 6. Now we have to identify what word we're using. This is a less than symbol, so it's going to be an and graph. And let's continue and do our other inequality, x minus 5. Now flip your symbol greater than or equal to and change your answer to a negative 6. Now we can solve both problems, add 5 to both sides. And x is going to be less than or equal to 11. Add 5 to both sides. X is going to be greater than or equal to negative 1. So our solution is that x is going to be less than or equal to 11 and greater than negative 1. You can also choose to write your inequality like this. Now you can only do this with and inequalities. All right, so let's go ahead and graph this on our number line. We want values that are greater than or equal to negative 1. So here's negative 1. We're going to have a closed dot. And values that are less than or equal to 11. I'm going to need to extend my graph for this. I have 9, 10, 11, 12. So here's 11. It's going to be a closed dot on 11. And we want to shade in between our two dots because those values represent numbers that are both bigger than negative 1 and less than 11. So there's our solution and there's our graph. Let's continue with number 3. X minus 7 is less than or equal to 4. So we're going to break this into two problems. X minus 7 is less than or equal to 4. Look at your symbol. What is the word? It's an and because of the less than symbol. Our other inequality will be x minus 7. Flip your inequality symbol and make the 4 negative. Now we can continue by solving both inequalities. Add 7 to both sides. X is less than or equal to 11. And add 7 to both sides. X is greater than or equal to 3. So with this problem, x is going to be less than or equal to 11 and greater than or equal to 3. Again, you can write your compound inequality like that, or you can write it with the variable in the middle using less than symbols, in this case less than or equal to symbols, smaller of the two numbers on the left, and the larger of the two on the right. So again, either of these answers is acceptable. Now let's go ahead and graph. We want values greater than 3, greater than or equal, so that tells me to shade in, and we want less than or equal to 11. So there's 9, 10, 11, 12. So there's 11, and I want values less than or equal to 11. So we're shading everything in between 3 and 11. Number 4, 3 plus x plus 7 is less than or equal to 10. All right, notice that that absolute value is not isolated. We have to get rid of the 7 before you can break it into two separate problems. So we have 3 plus x is less than or equal to 3. Now we can split it into two different problems. 3 plus x is less than or equal to 3. Look at that inequality symbol. It was a less than symbol, which tells me I need the word and. Now my other inequality is going to be 3 plus x, flip the symbol, greater than or equal to a negative 3. Solve both problems, subtract 3 from both sides. X is less than or equal to 0. And solve the other problem, subtract 3 from both sides. X is greater than or equal to negative 6. So here's our solution. You can choose to write it like that, or you can write negative 6 is less than or equal to x, which is also less than or equal to 0. Either of these is correct. And if we go ahead and graph it, we have a closed dot on 0 and a closed dot on 6. Negative 6. And we're shading everything in between. All right. Let's go ahead and continue. Now we're going to take a look at the OR inequalities. So again, we're going to do the same exact process. Separate our problem into two individual inequalities. 2x plus 1 is greater than 5. Look at that symbol. It's a greater symbol. That's why we know to use OR. And then write your other inequality. So 2x plus 1. Flip that symbol just like we were doing before and make the 5 negative. So now we're going to go ahead and solve both of these inequalities. 2x is greater than 4. Divide by 2. X, whoops, and I need to go back to my pen. Divide both sides by 2. X is greater than 2. Subtract 1 from both sides. 2x is less than negative 6. Divide both sides by 2. And x is less than negative 3. So our solution here is that x has to be greater than 2 or less than negative 3. So if here is 2, I need to be greater than 2, so I'm going that way, or less than negative 3. Here's 3, negative 3, and I want values less than negative 3. Okay, we're going to go ahead and skip number 6 and go on to number 7. We're going to come back to number 6. All right, number 7. Notice that number 7 is not by itself the absolute value. So we have to get rid of that 5 before we can break our inequality into two problems. So the 5's cancel, and we have 3x plus 6 in absolute value bars is greater than 3. Now that the absolute value is isolated, we can break our problem into two separate inequalities. 3x plus 6 is greater than 3. It's still an OR problem because of our symbol. And our other inequality is 3x plus 6. Flip the symbol, make that 3 negative, and there you have your two inequalities. Subtract 6 from both sides. 3x is greater than negative 3. Divide both sides by 3. X is greater than negative 1. Now do the other inequality. Subtract 6 from both sides. 3x is less than negative 9. Divide both sides by 3. X is less than negative 3. So our solution is that x is greater than negative 1 or less than negative 3. So here's negative 1. We want greater than negative 1. And less than negative 3. Here's negative 3. Less than negative 3. All right. There are two problems left. Number 6 and number 8. Do number 6 and number 8 on your own and check them with an adult.